Hello and welcome to another video. Today I'm going to be testing the Volinga suite, an Unreal Engine plugin, and the latest plugin offers the ability to be able to light your Gaussian Splats inside Unreal Engine, something I've not previously seen with Gaussian Splats before. Now Volinga has been around for a while, but this latest suite I think has only come about the last couple of days. It is all in beta, so there is some experimental features. As with most of these Gaussian Splat plugins in Unreal, they rely on point clouds and are generally quite inefficient running in Engine, but we'll get to that later on. The first thing you've got to be aware of with this is that the freemium version has some caveats, mainly a watermark on your splats, and secondly there is some limitations, I believe, in using PLY format and obviously using your creations commercially. With the 1 month free trial, it's always good to have a quick look at the terms and conditions when using any of these applications. Specifically down here, it says here, in accordance with the terms and conditions it's established for each type of users in section 1.1 above, Volinga reserves the right to use the data, images or any contents incorporated by freemium into the platform for learning improvement of the system, such as training, teaching or any other purpose Volinga considers appropriate. I would take this as be careful what you upload. Now Volinga, like many other platforms, allows you just to drag and drop files in here, and indeed I believe it offers a viewer here where you can view Gaussian Splats, again like many other platforms, and share them with the public and even download them. In such cases these are NVOL files, and we will be working with the PLY format today, which is more universal across different applications. The suite and the plugins can be downloaded from here. The plugin we're going to be using is for Unreal 5.5, and if anyone doesn't know how to install these, so once you have that zip file downloaded, you can extract it, and you need to navigate to your C program files, Epic Games UE5.5, Engine, Plugins, Marketplace, and literally drag that in there. The suite itself can also be downloaded, and we will have a quick look at that in a moment. So with the Volinga suite, it seems to be very easy to use. I'll just go to new project here, choose a folder, name it, and here I can add a new asset or a new scene. There is a CoMap registration, which I didn't try, and I know that the latest Reality Capture 1.5 exports CoMap, but for some reason I downloaded the latest version and camera lens information wasn't working correctly for me, so perhaps this has been fixed or I did something wrong, but I'm still using Reality Capture 1.4. Here we can add a bunch of images. Now most people use videos for this. Because most of these data sets I'm using are pretty old, I am still using large images, which may not be preferable for Gaussian Splats. I believe in most cases these will be downsized, so I've used a Sony a7R IV. They're massive 61 megapixel images, so this could be the source of some of the problems I had when using this suite. Just to give you an idea of some of the images I'm using for this scene, it's semi-complete, as in I have some photos of the environment but not all of them. They're quite dark. If anyone can guess where this is, bonus points. Some are quite detailed. We've got some water here, which is always challenging for photogrammetry, so hopefully that comes out okay. And you can just go ahead here and add your images or your video into here to have a little look and see what happens next. Now I didn't have a great deal of luck with this dataset in Volinga, and in another dataset they all seem to get stuck for me at 68%. I didn't wait for much more than 20 minutes, but on an RTX 4080 I thought this might be moving a bit quicker, so I abandoned it and actually resorted to using Reality Capture and PostShot, which is a technique that I have demonstrated in previous videos, so I'm not going to go over that in too much detail. You can see it here. So as I said, I'm using Reality Capture 1.4.2. So I'm just going to load a preloaded one here. I'm not going to go over how I did this because this is well covered in previous videos, but I just do the align images at this stage. I don't do the mesh creation. And then under alignment here, we can export the point cloud and the registration. which again I've covered in previous videos. I'm using a version here which seems to be missing a crop box, which again I haven't seen before. And what I did here was train this for about 30 minutes, as you can see here. So this is my resulting splat, and I have cropped it somewhat. And it hasn't come out too badly in some of these areas. As I said, there's only probably about 180 degrees of coverage here. But what we're going to do now is to bring this into Unreal and render it with Volinga. So for that, I'm going to export radiance fields, and I'm going to save that as a PLY file. It's about 700 megabytes. Now there is an additional part of this workflow that I tried to make work, and certainly does work with some other plugins, and I'll show you what that is. There's a Kiri engine plugin for Blender, because whilst I was editing this Gaussian splat in PostShot and I was missing a crop box, and it was really starting to annoy me about how clumsy the cropping and editing tools are, I thought I wish I could do this in Blender. And Kiri engine has written a Blender plugin that I recommend you get from their GitHub. And again, you can just download the zip for this. I'm using version 3.0.0. And I believe now in Blender you can literally drag this zip file into your viewport and it will install the plugin and make it active for you. I think it's a Blender 4.2 and above you need to use this. I'm using 4.3. And if I do that correctly by dragging the zip in here, if I press the N key, I should see the 3D Gaussian Splat by Kiri engine here. So what I'm going to do is use the import box here to import PLY as splat. Is that what I do? Yep. And it takes some time to work with this because it is quite a large file, and even a 700 megabyte FBX or OBJ can take quite some time to load. Now once I have this in, I can actually click this one to see the rendered view. And there is rendering features in this plugin which are really useful if you don't want to use Unreal Engine. In my case I do, and I am going to edit like I've edited photogrammetry in my previous videos by going into X-ray mode here and pressing tab. And again, this all takes a long time and is quite slow and quite clunky, but once you get there in the end, you can actually edit these just like you would a mesh, which offers a massive advantage, I find, over some of the tools that you get in PostShot or any other Gaussian splatting tools. So I can just highlight these verts and just get rid of some of these excess verts here. And this does get slower and slower as you do it more, so what I recommend is to save this as you go along. Again, pretty slow performance here, but I'm going to crop something like that out of here. And also I'll take a chunk out of here as well. Now you can use lassos and manually choose points and all those great tools that Blender has for editing points to get far more control over this, or you don't even have to be using points. You can use mesh faces, which I'll show you how to do in a moment. So if I go here and press the free key, I can go in here and manually choose planes and then delete them as well if I want to, like so. Let's have a quick look and see where we are. I'm going to choose the lasso here and highlight some of these points here in edit mode. So when I'm finally done, I can export again. So what we're going to do next is just to create a new project in Unreal. And I'm just going to go games blank here. And I'm going to activate the Volinga plugin as soon as I've opened it. I'm just going to go plugins here and just search for Volinga renderer, turn that on and restart. And once you've started Unreal, you'll have this little box here which allows you to import your Gaussian splat in. I'm just going to create a completely new level because I found that this doesn't like directional light. Maybe this will be improved in a new release, but I'm going to go with empty level here. And into this empty level, I am going to import my PLY. And I'm going to drag that in there. and just put this at 0, 0, 0. So we can see the Gaussian imports here quite well. I'm just going to do a little stat FPS here, which will show me my frame rate, which is always interesting to see when using these Gaussian Splats softwares and watching it change. As I said earlier, it is a rendered point cloud, so they're not the most efficient, and one of many reasons why I prefer to use photogrammetry, but we can see perhaps some of the advantages here, maybe with shiny and reflective surfaces like this water. Again, it's not a very complete splat, but let's have a look at why we're here and see how this lighting works. So I am going to go to lights here and grab a spotlight maybe, and push this spotlight up, and maybe place it there. And at the minute nothing's happening, but what I'm going to do is just to click here to enable the, there's not really a way of telling whether this has been enabled or disabled, but I think what we need to do is turn off the ambient light first. So we'll turn that to 0. And I found that if I change these thresholds to maybe 0.15 and then switch back to method 2 here, it seems to do its job. So there we have a part of this that's lit up. And as I move my light here, we can see more of this lighting up. So this is definitely something I haven't seen before with Gaussian Splats in Game Engine. And it could have loads of uses. If you wanted to highlight different parts, you could set up some basic scripting to activate and deactivate these lights. And what I'm going to do is maybe just pump this up to about 12, bring the spread up ever so slightly, and then maybe change this to a colder color in this case. It looks awful, but we can see that it is being affected by the color of the light and the brightness of the light and the radius here. So let's maybe copy this one and turn this one round to highlight another part of our splat. We can see some bits there that haven't been cropped properly, so might want to set up some cameras here or something. You see 2 different point lights there. Let's press G to turn off game mode. We still see that horrible watermark, but we're seeing 2 lights here and we're not seeing a significant frame rate drop with the 2 lights on the splats. Let's try a little point light here in the middle, and we'll color this one maybe purple. That looks awful as well. And I'm going to bring the brightness of this one down a bit, and the radius there, and zoom in a little, and you can see all the different parts of the scene lit up by different lights here. Now there is limitations, but for the best part, this could be something that could be very, very useful, certainly in virtual production if you're trying to match lights with backplates and so forth. If you're doing some kind of arc viz, some kind of torch based thing, first player experience, there's multiple uses for this. Even if you want to do some light color correction, you want to chuck in a couple of lights there to fix it, this has got all of that. If you want to download this scene, join my Patreon, and also to watch my other videos on other photogrammetry and Gaussian splatting techniques, and also how to learn how to use blueprints in Unreal, and drop me a comment either on the Patreon or below if you need any help with any of these. Thank you for watching.